I'm Oliver. I'm the software engineer at Electrobit Automotive, and I'm really happy to be here to present you some use case, some real-world use case about Ankaios and using it with AI-driven edge analytics for software-defined vehicles. And I'm really looking forward to an open discussion round afterwards and to a really interesting Q&A. And if you want to share feedback or want to find out more about Ankaios, you can also join our Ankaios Slack channel. The QR code is displayed here, or just write me an email afterwards. But yeah, no worries, this will be displayed at the end again. So let's have a quick look over the agenda. So first, I will start with an edge analytics use case, introducing to edge analytics. Then I will show you a concept for edge analytics, which is called Ankaios Intelligence. Then I will wrap up with a simple summary. And later, I have to share one more exciting thing about Ankaios. But let's put this to the end of the talk and start with some use case. And so in a software-defined vehicle, you have a group of applications, which is also called a deployment. And this group of applications performs a certain task. For example, you have a virtual eye assisting a driver, and you have multiple applications connected to each other performing this use case. And that's the deployment. And to handle this increasing complexity, the deployment is ideally managed by an in-vehicle software orchestrator, which is, for example, Eclipse Ankaios. And I want to underline this a little bit more, because you might have multiple kind of deployments. And a software orchestrator like Ankaios will manage you to handle this complexity and this integration. So think of the deployment inside the vehicle is up and running. And also your software orchestrator shows you that every application is up and running inside the vehicle. And for example, you update app 2. There might be some issue with application 2. And you don't have those insights right into your vehicle. And even if you would have, automotive application seems to be very robust and do not fail on each simple issue. And they might stay up and running. And also your software orchestrator will show that. So if you don't have those insights about your deployments inside the vehicle, how do you know that everything runs smoothly? And for this, edge analytics can generate those insights to detect and find out broken deployments and what's the root cause of this. And before showing you some concepts, let's define edge analytics as a term in general and put it into the context of a software-defined vehicle. And edge analytics in general means analyzing insights in real time, and almost real time, directly from the devices where the data is generated. So this means at the vehicle, at the edge, at the source. And let's put it into the SDV context. So you have a generic orchestrator orchestrating different kinds of deployments and applications connected to each other, very generic. So what we want to do is we want to somehow analyze the application logs continuously on the fly during their running. We want also to detect anomalies or issues at an early stage. For example, here, app 2 might suffering from multiple connection retries, which has a huge impact to the whole deployment. And your deployment will be broken. But you don't know because you don't have these insights normally. We also want to keep most of the data at the edge, so keeping most of the data private, because that's the key essence of edge analytics. And like said, we want to find out the root cause. So what is the impact of the deployment and why it's failing? And this helps us to stay reactive to increasing complexity, which is introduced by software-defined vehicles because of frequent updates and upgrades. So now that we know what edge analytics means and what is the context to the SDV, let's jump into the concept itself, which is called Ankaios Intelligence. And before talking about the concept in details, let's define some expectations again. What is the proposed outcome? So like said, we have a software orchestrator that generically orchestrates different kind of deployments and applications. But we also know that the vehicle is not a cloud, right? So if we want to first detect somehow anomalies inside the vehicle, we need an anomaly detection pipeline that's very suitable for embedded systems, because a vehicle is still an embedded platform. Furthermore, you might have seen also a lot of Eclipse SDV projects, and they have different log formats. And we want to be independent of those log formats. You have U-protocol logs, MQTT logs, CUXA logs, DLT logs, which is also pretty common in automotive. But specifying all log formats manually for continuous analysis is a nightmare if you have a lot of applications. And then there is one more thing. You need an intelligent eye looking at the log stream of those applications on the fly during their running, and to find out anomalies, of course. But just detecting the anomalies is not enough, because you want to do more with it, okay? For example, you want to generate a report about your fleet, or you want to automatically create bug reports, okay? But for simplicity, let's focus on root cause analysis on this talk. So why is the deployment failing? What is the root cause that it's broken, okay? So at the end, you need a flexible end-to-end edge analytics pipeline, because only detecting anomalies has no value add and is not enough. And let's see how we can fulfill this high-level concept. And what we want to do is, we want to combine edge analytics with software orchestration. And thus, Ankaios Intelligence was born. And why should we do that? Well, there is a good reason, because a software orchestrator like Ankaios has pretty much and very good direct built-in functionality for streaming logs of different workloads, because it has an API that workloads and applications can use. So if we start Ankaios Intelligence, which does the edge analytics parts, as a separate application managed by Ankaios, it can connect via the so-called control interface and can stream logs of other applications in an authorized way, which is pretty good, because now you know how to get the logs safely and streamed during other applications are running. But now that we know how to get the logs, let's focus on some AI and good intuition about how to detecting anomalies. And you probably have done it a lot, or doing it a lot of times. You have some log sequence, and you ask the large cloud models like Claude or GPT, hey, maybe there is an issue, find out for me what's going wrong and tell me the root cause. And that pretty much works well. And for our journey, we ask ourselves, can we transfer this kind of intuition to find out anomalies and their good text semantic understanding inside the vehicle? And we tested a lot of small language models with different parameter sizes. And for example, here is an example you can see, even without training, with prompt engineering and all that stuff, they have pretty much good intuition about text semantic to find out some anomalies inside a log sequence. Here it's pinpointing that there is some MQTT connection issue, and it's doing that well. But we find also out, without further information about the deployment, so how are these applications are connected to each other and what's the use case, they can only provide more intuition about finding anomalies, but not telling you an exact root cause why this happens and what's the impact to other applications affected by this one broken application. That's a really important point. And so also, depending on the model size and the quantization, the key essence here is also of the slide, executing a model is still time-consuming and resource-intensive. So take these numbers only as a baseline and not too serious, but it takes time and it's resource-intensive. And as vehicles are still embedded platforms, like mentioned at the beginning, GPUs for edge analytics may not be available for continuous analysis all the time. So, well, it would be really good to have this great intuition of the bigger and prompt-based language models, right? But the question is, if we are in an embedded world here inside the vehicle, we need somehow a different concept to tackle this. And I show you now this concept on one slide. It's a high-level overview, and I go into some details in the next parts of the presentation. And what we propose is still a hybrid approach for an end-to-end edge analytics concept. And what we want to do is we want to detect the anomalies and issues using an extensible chain of semantic analysis inside the vehicle. So we need smart detectors inside the vehicle suitable for the embedded platform there. But we want to invoke the larger LLMs with their great intuition for exact root cause analysis in the cloud, and probably also with a human in the loop, because you know in edge analytics you have false positives. So a human in the loop is very good, and to connect a natural language interface is pretty much common standard these days. Also in the cloud, there is one reason, because in the cloud you have system specs and you have requirements and also a lot of dynamic data which you can use to enhance the LLM's capabilities for detecting root causes more properly, right? These are not available inside the vehicle. And let's focus on some example of semantic analysis chain inside the vehicle, so how to detect those anomalies first. And before doing that, I want to catch up something from the beginning. We want to be somehow independent of the log format. And here is one concept how to do that. We found out that the larger cloud LLMs are really good in constructing regular expressions. So the Ankaios intelligence workload, which is doing the edge analytics and the anomaly detection, if it sees a new log line, it will send a sample line to the cloud. And the cloud LLM will just construct the regular expression, return it, and in this way, we are independent of the log format because it can use this regular expression to create a structured log, which can be then used for post-processing. And of course, if you would start the deployment in production again, this regular expression can already be reused and stored. But we have a structured log now and don't have to specify every kind of regular expression manually or some log templates we all know from the past. That's unhandy. Okay, now let's go into the semantic analysis chain. And of course, we have some fast and resource-efficient anomaly detectors still. And the idea is to invoke more costly analysis only when required to run, because we want to run log analysis without causing disruption on running deployments. But I don't want to focus on the easy ones like log severity check. I want to show you a concept that has more intuition to find out some anomalicious log lines. And I want to show you how to build an efficient generic log classifier using some newer AI concepts that might be suitable for the embedded platform inside the vehicle. And with this, I mean, forget the things you train specifically for each application and for a specific log format. This should be somehow independent and better with new AI concepts. And let's put some look to it. So the question is again, can we preserve somehow the intuition and text understanding similar to the small language models, but with being more in-vehicle friendly, or in other words, more CPU friendly? And what you need is you have a log body and you want to classify it just as a human looking at the logs. Well, this sounds not great in the logs. There is some out of memory, for example, or this application has some troubles. So you throw in a text snippet and it would output a label, but very generic. And we found out that there is a set fit framework, which seems to be very promising. And I wanted to show you short what this is. Set fit is a prompt-free framework, and it's specialized for text classification. So it's very suitable for classifying logs, we find out. And the main key point is that it's really, really fast to train. And the accuracy is high with very little data. In the documentation, which is linked also below on the slide, you have like 8 labeled data versus 3,000 on larger models, which sounds really promising. The magic is not too big. So you have a log body still, it's converted to embeddings, and then you throw it into the classifiers, and then you get a label out of it. But you can train with this concept a really, really generic log classifier that understands very well if something goes wrong. And we did that and also compared the performance. And with SetFit, you can use very small models while maintaining stable accuracy compared to larger models. And if you want some great log classifiers or text classifiers, you probably use a zero-shot model, which is in the billion parameter space. So 0.4, 0.7 billion parameters. But with SetFit, you can have the same accuracy with very little data, but you shrink the model size to million parameters, only 60 million. And this has a huge impact on an embedded platform, because if you compare the inference time here on the slide, you have, for a zero-shot classifier, you have 0.5 seconds on an embedded platform like a Raspberry Pi 4, right? Which is very long. But with SetFit, you have only 0.1 seconds. So this is a huge improvement here. But not being more technical, let's go one step further. As hardware and software is also improving a lot, also inside the vehicle, let's assume that a GPU might be available for edge analytics. And like our proposed pipeline is flexible and can also be cascaded, you can still extend your analysis chain with some small language models that are optimized for edge device execution, which is, for example, in LLama 3.2. You can have 3 billion, 1 billion parameter. But the key essence is we can increase a lot of intuition finding the anomalies in a stream of application logs, even without training. So if you do prompt engineering that's not specific for any application logs, but focuses to have the output in a more structured and well-formatted way, some LLMs are still able to detect, for example, here that the speed value in an info log might indicate an invalid sensor, an invalid speed value, just because of its general knowledge of physics, it's being able to see that a speed of 2000 could be an indicator of an unusually high speed and a malformed sensor input. And it can also automatically assign an assumption about the severity and the confidence. Okay, so also small language models are very great to detect and find out anomalies. I want to finalize the concept once with the cloud view again. So we send only the minimum needed data to the cloud for doing root cause analysis, so this keeps most of the data private. And we invoke here the much larger models like GPT or Claude, which you can enhance with a lot of great input like system specs and also dynamic data to get out what's the root cause of some failing deployments. And there you have also the human in the loop, which can also prevent you from some false positives. But we can also see later that AI can do that. So I know what you are thinking now. This guy only has PowerPoint slides. But since I'm said at the beginning, I'm technician and software engineer, I know what we guys think. PowerPoint, right? What's PowerPoint? Long story short, I have a simple demo. And it's about a commercial driver grading system. I know you're rolling eyes. Driver grading system. I don't want to talk about that, okay? I don't want to judge anyone. But we need a sample deployment, right? So just some applications connected to each other performing a use case. And for this, it's enough. And let's go through it really quick, and then I show you the demo. So on driver grading commercial side, we have, for example, an AI video analysis component that just detects some distractions of the driver looking too long on the infotainment or out of the window. But we have even more metrics to analyze the driving behavior. We put in some vehicle dynamics like speed, harsh steering, harsh braking. And this is evaluated somehow in a driver grading unit, and you show warnings on the infotainment to the driver directly if the driver is distracted, but it doesn't matter. The more important thing, you sync it to the cloud and to the central fleet management, and you report driver distractions or bad driving behavior. And then you have your Grafana, for example, showing you some statistics, but just as an example. I will go to the demo now. And you can see here just a simple example dashboard. And we see that for a vehicle, there is some bad driving behavior reported, some harsh braking, harsh steering. But at some point, it seems like we only get some driver distractions. So for example, driver is looking out of the window or on the infotainment screen, and we ask ourselves, or let's say maybe we don't ask ourselves because we still get data, why don't we get some bad driving behavior anymore, right? Is the fleet behaving better now and just distractions are reported, or what's the thing here is? And we also know we have updated the vehicle dynamics workload, for example, in the last week. And what could be then even better than asking our end-to-end edge analytics pipeline by just asking, how is the fleet? And okay, let's wait some second. And we get a quick overview about what's going on inside the deployment, right? And I want to show you, before moving to that just as a quick overview, the whole deployment is still up and running, okay? But also the Ankaios intelligence workload is running next to the other applications doing the edge analytics. And let's go back to the AI analysis. And what we can see is that it says all workloads are up and running, but there seems to be anomalies, different anomalies. It also is able to detect some false positives because it knows the system specs and the requirements. So even if your vehicle analysis would send some false positives, it would get filtered out because it knows the requirements and the system specs of this deployment. Let's just move quickly to the real anomalies. And it seems like there is some problem in the vehicle dynamics application we updated last week, because a speed of 2000 and a steering angle of 100 degrees is not according to the system specification. And this could be found out by a clever edge analytics pipeline. We also received some more malformed inputs, and we get a quick summary. So AI is very good at doing that. And you have seen with one prompt, you are close to the insight into the vehicle about what's going wrong, even if you think at the first steps, all is up and running and it seems okay because I still get data somewhere. And then you can do the fancy things you already know, create a bug ticket for something like that. And then you can also use the more flexibility of the increased flexibility of the cloud LLMs to connect all the tooling so that your edge analytics pipeline makes sense and is an end-to-end concept. And you would see it generates a descriptive title, also which vehicles are affected. You get a root cause description that the system spec values are not hold and there is some issue with a workload, some evidence logs as a proof, and also first seen and last seen. So one was the anomaly first seen and last seen. And you can do that with pretty much almost no training. So for this, we don't have trained something specific. We can go back to this in the Q&A again, but for now, I want to continue with the slides. And so let's wrap up in a simple summary. And there are 3 major points and key insights you should take away from this talk. Combining software orchestration with edge analytics makes sense because you have a monitor and some intelligent eye looking for broken deployments. But also with you need a smart and extensible in-vehicle anomaly detection pipeline that's in balance with your hardware resources. So if you have, for example, GPUs available, you can increase your intuition by doing more fancy stuff and invoking small language models. They're really good in it. If not, I have also shown some concepts how to have something for more CPU-friendly environments. But only detecting the anomalies is not enough because you need an end-to-end edge analytics pipeline because you want to do something with those anomalies. And like said, for example, root cause analysis I have shown in this talk to find out why a deployment has some troubles and why it's broken. Now, I want to share one more thing about Ankaios. We already have seen that S-Core 060 was released, and I want to share something similar. So for now, we have released Ankaios version 1, which has now a stable API, a lot of new features, a unified API, new features like events, so you can send workloads events using a built-in orchestrator feature, which is also really suitable for automotive use cases. And like always, we have done many improvements and bug fixes. So this QR code will lead you to the Ankaios version 1 release. So if you're interested, then have a look there, check it out, try it out. If you find something, then like always, open an issue or also contact us at the Slack channel. Or if you want, you can also contribute a pull request. We are really happy about that and will definitely support you there. And I think now it's Q&A time. Thank you for your attendance. And yeah, I'm really happy to be here. Thank you.
Questions? Okay, well, yeah, Ansgar.
If nobody has, I
also have one.
Thanks, Oliver, for the presentation. And it's pretty much not a question, but more something I would like to add or even celebrate here, because what we completely lost between the lines, Oliver had it on its slide, and you correct me if I'm completely wrong, Zara, but I believe that Eclipse Ankaios is the very first project within the Eclipse SDV community reaching a 1.0 release. So congratulations to that.
Thank you.
Yeah, well, we will have a graduation party later.
Okay.
So maybe a question. Is the intention of this log faults detection to run real time on the car down the line? Because that could also be a guardrail, you know, when you have mixed criticality system, that could be a guardrail in a way.
Well, you can also think about storing some selected and filtered logs, and then you run the analysis part if the vehicle is at a parking slot, because we have all those functionality that it's learning when you are using the car and when not. And so you can find maybe a good trade-off about using the resources at the correct time then for doing this. Yeah.
Okay, that makes sense. Thank you so much, Oliver.
Yeah, thank you too.
Okay.